Okay, so in the previous video, we learned how to use Docker by itself, how to download Docker images, how to run them, how to run containers, how to control those containers, how to execute new commands inside those containers, how to access those containers, how to examine them, how to hit them over TCP/IP ports, etc. Now, if you didn't see that, please go back and watch that video before you get here. But in this video, we are going to learn how we can combine multiple Docker images or Docker containers. So that for that we will use Docker Compose. So Docker Compose lets you combine multiple containers into a set of containers. It lets you mount volumes. It lets you forward ports. Lets you set environment variables and container labels, etc. All of this in a file as opposed to on the command line, which of course is very helpful because that file can be, saved on disk, and then you don't have to type all those commands all over again, and you can also version control that file. So to learn more about it, you can go to this place, so which is this guy here. This is that website, which docs.docker.com/compose/compose file. It defines the format of this. So let's create a new file. Okay, I'm going to create a new file called docker-compose.yml. Okay, the first thing that goes into it is the version number, and the version number is put in double quotes. And the most recent version is 3.8, but I'm using 3.5. It depends on the version of Docker and Docker Compose that you might be using, but don't use anything earlier than 3.4 or so. Okay. All right. So you specify the version, and then you specify services. So this is YAML file. Hopefully you know the syntax, but it's very intuitive. You just indent with 2 spaces, because what I'm about to specify next is a child of services object. So under services object, you have another object called whatever the name of your service is. So I'm going to run, let's say, nginx as a static web server. So first I will serve some files through nginx, and then I will also combine the nginx service with um, the other service, PHP service. So let's say I create a service called nginx, and it uses an image. Um, there's the image, and the image name will be nginx:latest or something like that. But I don't want to use that one. I want to use something that I already might have. So here, if I say docker images or image ls, that will tell me what I have. So nginx, yeah, there it is. It's 119.04 alpine. So let's use that. So that's the name tag I'll use, and I can run this. But instead of calling the service nginx, let me call the service something more generic like web. Okay, so let's just save this. This is it. This is a functioning Docker Compose YAML file. Let's take a look at how it works. So I will just run Docker Compose up. So earlier, this is equivalent to saying, this whole file is equivalent to saying copy this, and if I said docker run this, that would be the same thing. In fact, yeah, so that would do the same thing. If I say docker run -d and then give it a name, I'll give it a name of I'll just say foo. So if I run that, it's running nginx, and if I say docker container inspect foo, that's the IP address. And if I put that IP address in here, you see that's the nginx that I just started. Great. So that's nginx running, but that's through command line. Let me do the same thing. Let me first stop this container stop foo, also remove the container. Okay, so now I will instead use docker compose to do the same thing, and this will give it a name based on this service name. It'll use the same image. So let's save and say docker compose up. But again, if I press enter at this point, it will occupy my terminal. So I say up -d so that it detaches from the terminal. And now it's running. Now if I want to find out what containers it created, I could run docker ps, and let me make this a little smaller so that you can see. There it is, docker web, docker underscore web underscore one. This is the one that it just started. It derives the name of the container from the name of the service, which is web, and the instance number, which is 1, and prefixes it with the name of the directory that the docker compose YAML file was in. So that's how it determines that's the name. So if I now go and make this larger and I say docker, let's make it docker container inspect and the name of the container. Now that's the IP address. Copy the IP address, put it in here, and that's the same thing. I mean, of course, we did not expect anything different. But where is it getting this front page from? The answer is, it's if we can find out the answer by looking at, we go inside the container. Now remember, we are using docker compose. So instead of doing docker exec, I'll do docker compose exec. I do not need to specify -i and -d as we learned earlier. We don't have to specify in docker compose. It applies those options by default. Then you give the name, not of the entire container, which would be this, but just the name of the service, which is just web. And then the command, which is shell, of course. So we go inside, we cd to etc nginx, and the default website is served from conf.d, and in there is default.conf. This file, its doc root is user share nginx html. Okay, so we go and cd to that directory, user share nginx html, and there is an index.html. If I cat it, whatever is in there is what is being served here. Now, this is where Docker Compose shines. Obviously, this is your application. You don't want to serve the default front page of nginx. So let's create our own application's front page, and we won't do that inside the container. We will do that inside in our host. So we just create a new public HTML directory. Public/index.html is the file we are creating. We will, in that, we will create an empty-ish, a very simple front page. We'll call it docker compose demo, or nginx demo, right? And here we will also use the same thing as and heading 1. Save it. And now this is not enough. We have to now mount it in the same exact place. Remember, in the same this place. So let's copy this directory and go into docker compose YAML and mount a volume. So we say volumes, which is an array. Remember, this is under the web service. Volumes of array, which means we indent it and start with a dash. And then the host path of the volume, which is current directory /public, and the container path of this volume mount, which is user share nginx html. This is where nginx is going to look. This is the path that is the doc root of nginx, and that's where it's going to look for index.html. So save this. Now I don't have to, I'll exit the container, but I don't have to kill and this and stop and recreate and all of those things. I can simply say, because I made a change to docker compose YAML, I can simply say docker compose up -d. And that simply recreates the machine. Now it may or may not have changed the IP address. Let's see. If I inspect again, if I inspect, and the IP address is 172.22.0.2, which is the same one. So if I now reload, look, docker compose nginx demo. Excellent. If I make any change to this file, the index.html file, let's just add a paragraph, and I'll say welcome, save it, reload, and you can see welcome. Excellent. So this is already very, very useful, right? But it gets better. Imagine that you did not just want to serve static HTML files, you wanted to also do some dynamic stuff. Let's say with PHP. Okay, so we will create a second container, a second service actually, based on PHP. So let's do that. So I open a new service. Under services section, I have a subsection called PHP. That's the name of my service. And the image is going to be PHP colon, let's say 7.3-fpm-alpine. I like alpine images. They are nice and small and they're very efficient. I give it the same exact volume also. I have to give it the same volume. If I don't do that, it won't have access to this, to this same path, because nginx is going to reverse proxy the request and forward it to PHP. And of course, PHP should have access to the same PHP file. Let's do that. So if I create a PHP file, and now that we have this, let's create a PHP file. We will create in public, create a new file called test.php. And if you don't know PHP, don't worry about it. It doesn't even matter. We are just putting in a very simple PHP info command. It'll just dump some information about PHP's, how it was built and what kind of extensions it has and what variables it has and what settings it has. Okay. So in index.html, let's give a link. So we copy this, a href, and link to test.php. And then here I just specify the name test.php. So once I do all these things, I can reload. There's a link to test.php. I click on it and it downloads test.php. Instead of running test.php, it downloads it. Well, that's because, first of all, the docker compose, remember docker compose, you can run ps to see what is running, and it is running only in this docker compose YAML. It is running only the web, not running the PHP part of it. So we can fix that by running up -d again. So now it's created PHP service, but if I now do docker compose ps, it still is, so now it's running the PHP FPM and nginx as well. Okay, now let's see. If I reload, click on, it still downloads test.php. It doesn't actually run it. So in order to make it run, what we have to do is we have to modify the default conf. Now, if we want to modify default conf, we should not do it inside the container. Although we can, yes, but we should not. Why? Because the containers are transient. You might destroy the container. So you need to keep it outside in your host. And so you should version control those files. So let's copy the default.conf. We say docker cp. We use the docker cp command. There is no equivalent in docker compose for that. You give it the name of the container and the path, which is etc nginx conf.d / default.conf. And then this is the file we want to copy. So let's copy it to current directory here. And once I do that, I have the default.conf. This got copied from inside the container into the host, but it needs to sit in a particular place, etc., etc. So why don't we I mean, yeah, there are many ways to do it, but I'm just going to create a folder called docker/nginx/conf.d folder. It helps me understand where this file should be sitting when it comes to the container inside the container. So I'm just moving this default.conf under docker nginx conf.d. Now we need to mount it. So to mount it, we go to docker-compose.yml and add to the web nginx container. We add. Remember, we created it under docker nginx conf.d. I can mount the directory. I can also mount the file itself. So, but it's going to be, let's do the directory. Docker nginx conf.d mounted to etc nginx conf.d. Okay, once we do that, now when nginx goes looking for etc nginx conf.d/default.conf, it finds this file, not the other one. But of course, the reason why we copied this file at all was because we wanted to make some changes. So it has all these some information. It already has something for PHP. It's commented out. So when it encounters PHP files, it's supposed to do this. So let's uncomment these lines, and we do have to fix them a little bit. The root is incorrect. It needs to be same as the root that is specified in nginx's root, and so I copied that root. That one was incorrect. Second, fastcgi pass is passing the PHP request to 127.0.0.1 port 9000. Now it is listening, PHP is listening on port 9000 as you can see here, but it is not listening on 127.0.0.1 or the local host. Nginx is running in one container, PHP is running in a different container. In order for Nginx to access the other container, PHP, it has to access it by its host name. And the host name is, well, it's same as the service name, which is PHP. Now, the web container will be able to access the PHP container at port 9000. So that's good. Finally, this fastcgi param script file name, well, this is incorrect. If anyway, it's just delete it. And more importantly, this fastcgi underscore params, that file is, well, for whatever reason, it's incorrect in this image. I will replace it with fastcgi.conf. Okay, let's see if this makes everything work. Okay, all I have to do is up -d again, and it should recreate the server. And I click on test.php, and wow, look at that. It ran test.php. Nginx did not run it. The second container, the PHP container, this container ran it. Nginx did not. Nginx, the web container, simply forwarded the request, proxied it, as you can see here. fastcgi pass. It proxied the request to PHP container at port 9000. It went PHP container, which has this same path mounted with the same files. It found the test.php right in there and executed it. That's so nice. So this is a basic introduction to um, Docker Compose. Now the possibilities are endless. There are a lot of other things you can do. You can say port, right now we are accessing it directly by the IP address of the Nginx web container. We could on port number 80, but if I wanted to expose it either to the public internet or to my local host, then all I have to do is add a ports section, and it's an array. So 8081, let's say, is the port where I want to expose it. But of course, so the left hand side, so there is a colon separator, and there is the left hand side, which is the host port number. And then there is the right hand side, which is the container port number. So Nginx obviously is the container it's running, listening on. Web container is listening on port 80. But then in the host, we I have other things running on port 80, so I want to put it on, expose it to a different port, so 8081. So I save it, I do up minus D again, and if I now, of course the old ones continues to run, but if I go to localhost 8081, I see my same website. If I click test.php, it still works. So this is how, now in this case, I'm putting localhost colon 8081. If my machine was exposed to public internet, then this would be available on public internet as well. And whatever port you forward it to is where it will show up. Now, typically on public internet, you do want port 80 and port 443, which are the standard HTTP and HTTPS ports respectively, to be exposed, for which you need a little more complicated setup with some kind of an ingress server or a traffic server or something. So that's an advanced topic. But for now, you can see how to expose to forward the container port to the host port. Okay. But this is, I mean, I usually don't do things that way. I run my Docker containers on a Linux machine itself. That's the other thing I wanted to keep emphasizing, that Docker runs very well inside Linux as a Linux host. So not only Docker containers themselves are running Linux operating system and Linux programs, but the host works best when the host is Linux itself. So I'm going to comment out ports. I'm going to comment out this whole section. And at this point, if I do up minus D, the local host stops running. If I bring it back, let's say, save it, and up minus D, it's back.